Hi, Ann. Uh, so to answer your question, you're asking about simplification. It looks like from your email you understood the calculus portion of it, how to use the quotient rule to fill in the blanks and get all this. So you're good to go with there. Check. And it's the simplification, the algebra. So here's the problem that you have listed. And your question looks like is how do you get from one step to the next. There's not a nice way for me to show that using Google Docs. I can't draw arrows and whatnot. However, what I can do is kind of point to it. So I'm going to use my cursor quite a bit as a way to point to what I'm talking about. What they're basically doing is they're factoring out the greatest common factor. And in this big mess of stuff here, it can be hard to see that. So I've drawn a smaller problem down here, or typed up a smaller problem. The original problem is 5x squared minus 10x. So we've got two groups, two chunks of things separated by adding or subtracting. So this is what we call a binomial. This is a monomial, one group, one chunk, all multiplication. And two chunks is a binomial. And that's really what we have in the numerator here. We have one big chunk here. We've got negative 5x plus 1 to the fifth. That's this piece times, so it's all multiplication, times 4x minus 2 cubed times 16. So this is one chunk. That's kind of like the 5x squared. And then we've got another chunk over here. And all this is multiplied together. We've got this negative 5x plus 1 to the fourth. I know there's a plus there, but this is considered one piece of the chunk times negative 25 times 4x minus 2 to the fourth. So there are two chunks. And what we're looking at is what's the greatest factor that they have in common. So for these two, we can divide them both by 5. We could also divide them both by x. So the greatest common factor between these is 5 and x. And so if we factor out the 5x from both of these pieces, from both of these chunks, we get this. We divided the 5x out of the first piece. We divided the 5x out of the second piece. They're doing the same thing here. The goal, the end goal is to try and find something that all three chunks, I'm including the bottom here now as a chunk, something that all three chunks have in common. They don't have a 4x minus 2 in common. The top two do, but the bottom doesn't. The bottom has a negative 5x plus 1. And so do the top two chunks. And so those are common factors. And really, the 4x minus 2, you could leave it. In fact, if I were doing this problem, I'd probably leave it where it is. However, I am going to walk it through because it shows up in the work in this example that they have here, where they factored that out. So they looked at the two chunks in the numerator and said they both have a 4x minus 2. They have 3 of them here, and they have 4 of them here. So we can pull 3 out of both of those. We can divide 3 sets of 4x minus 2s from both of these two chunks. And so they pulled out a 4x minus 2, 3 of them. And that's where they got the 4x minus 2 to the third power here, because they took all 3 of them from this first chunk, and they took 3 of them from this chunk, because they have to be divided out equally, and they left the 4x minus 2 right there. So that's that extra 4x minus 2 is left over. Then the negative 5x plus 1s, there's 5 of those pieces here. There's 4 of those pieces here. So if they pull 4 out of both chunks, there's negative 5x plus 1 to the fourth right there. There'd be one group of negative 5x plus 1s left over in that first chunk. The 16 is left over, and the 25 is left over. And I'll talk about the negative here in a second. The 16 and the 25 don't have a common factor. They're both perfect squares, and they're not the same number. So they don't have a common factor. The minus or the negative changed to a positive, changed to a plus, because we have a negative distributed times a negative, which becomes positive. So that's where that plus came from. In the denominator, to the fifth power squared, if you have a power raised to another power, you can multiply those two powers together. And that's where they got the 10 from. Now, what they ended up doing, almost last step here, is they said, okay, we have 4 negative 5x's plus 1's in the numerator. We have 10 in the denominator. I know there's this one extra over here, but we're just concentrating right there. And we're going to divide them away. So they divided away the negative 5x plus 1 to the fourth. 4 of those negative 5x plus 1's from the numerator. If you divide 4 negative 5x plus 1's from the denominator, you'd have 6 left over, which is where they got this 6 from right here, and which is why this negative 5x plus 1 to the fourth disappeared. It didn't really disappear, it divided away along with the 4 from the denominator. The reason this one didn't disappear, the reason this one didn't get divided away, if we go back to the top, the thing that they all three have in common, all three chunks have in common, are these negative 5x plus 1's. The most that we could take from all three equally is 4. So if you took 4 negative 5x plus 1's away here, if you took 4 negative 5x plus 1's away here, and you took 4 negative 5x plus 1's away to the bottom, you'd end up with 1 left over, and that 1 negative 5x plus 1 group is attached to the 16 with multiplication, and there it is right there, attached to the 16 with that multiplication. So the way that Newton did it is much more rigorous. They factored out the greatest common factor and then went from there. Another way to think about it is, as long as, and this is important, if there's an adding or a subtracting between the two big chunks, between the two big groups, then they both have to have the same number in common, the same thing in common with whatever it is you're dividing from the bottom, from the denominator. Greatest common factor is probably the most rigorous way to do it, and leads to the fewest mistakes. So that's what they did there. Then after they did that cancellation, got to this point, they distributed. Again, lots of distributing. So they distributed through there to get this, and then they combined like terms and stopped there. In fact, I take that back. It looks like they then factored out a greatest common factor with the 20 and the 34. And the 20 and the 34, and got the 2 from there. So that's the process. That's the factoring the greatest common factor. Again, think about it as chunks, kind of like we did here, 5x squared and 10x, and then you're factoring out the greatest common factor from there to see what you can reduce and simplify. Hopefully that helps. And yeah, keep emailing me. Questions are good.